Okay, so we have to figure out what the reasoning is for caring about the electrons and where they live. First of all, we need to exactly be able to tell where they live, so we use something called electron configuration. Electron configuration is a notation to identify where electrons are in the ground state in an atom. Okay? Now, it's very helpful to use the periodic table when we're talking about electron configuration. Because when you look at the periodic table, you see that the numbers, the atomic numbers that we talked about in the last lesson, go up in order across the chart. Okay? You will also notice that the chart is kind of divided into different groups. There's a group here. Okay, there's another group over here. And then there's a group in the middle here. You could think of these as relating to those different orbitals that we just finished talking about. Helium goes with the group over on the left. So when you're placing electrons, you can think of the electrons that are going into the s orbital as going into one of these two columns. When you're placing electrons into a p orbital, you can think of them as going into one of these over here. D orbitals would be represented by these elements over here. The ones down here deal with the f orbital, which we're not going to get into. So using the periodic table, first we write the energy level that we're talking about, which the first energy level would be 1, followed by the shape of the orbital, which the first orbital shape would be an s, and how many electrons we can actually fit in that orbital, which of course is 2. So when we start with 2 electrons, we just start at the top of the periodic table, work our way across. Notice that we have taken care of all of the elements that are in the first period or the first row. That represents the first energy level. Now the second energy level is going to be represented right here by the second row. You can see a set of 2 that's going to represent the s orbital and a set of 6 that's going to represent the p orbital. So we are going to now put 2 electrons in the 2s orbital here and here, and then we're going to put 6 in the p orbital, which will take care of all of these over here. Alright, now if we move down to the next period and we move out from the nucleus to the third energy level, we are going to be filling the next s orbital and the next p orbital, which are represented right here in the electron notation, electron configuration notation. Again, big number to represent the energy level, letter to represent the shape of the orbital, superscript number to the right to represent how many electrons are in that orbital. Okay? Now you've filled up, or you've taken care of everything that's in the third period or the third row on the periodic table, but you know that there's another orbital set in the third energy level. You know that there's a d orbital, and actually a total of 5 d orbitals holding 2 each, or 10 electrons total. But because that is so high in energy, remember, the first thing that the electrons are going to do is to fill up the 4th energy level. 1, 2, 3, 4th energy level, s orbital, and then they'll go back and fill up the 3rd energy level, d orbital, with 10 electrons. And then, of course, after that, we can place the next 6 in the 4th energy level, p orbital. Okay, now, if we've done that and we have placed a total of 36 electrons, we have then placed all of the electrons for this element right here, which is krypton, and which has an atomic number of 36. Pretty neat, huh? So you just go across the periodic table, placing electrons, thinking s orbital, d orbitals, p orbitals, energy levels as you go down. And when you get to the element that you're talking about, you've placed all of the electrons that you need to place. Alright, so we said that was krypton. We can also look at the electron configuration notation for neon, which is right there, and then the electron configuration for argon, right there, and then there's a few more here. This one is going to get us to chlorine, we will notice. And here's another one. This one gets us over to oxygen. And then the final one on the page, over to 3D8, which is nickel. Okay, so the reason that I've put all of these up here are so that you can hopefully see a pattern. In krypton, which is over here, copied, you see that in the very highest energy level, which is energy level 4 in this case, it's not the highest energy level that you could have, there are a total of 8 electrons placed. For neon, which ends up being over here, the highest energy level is 2, with a total of 8 electrons placed. And then for argon, the highest energy level is 3, and again, we have a total of 8 electrons placed. Now let's look at those. Here's neon, here's argon, and here's krypton. They are all in column 8A. Everything in column 8A has 8 electrons in its highest energy level. Those are called valence electrons. Every reaction that you see in nature is because the elements are trying to end up with 8 valence electrons in their highest energy level. The noble gases, the elements in column 8A, have 8 valence electrons, and everyone else wants the same number. So all the reactions that you see again are because the elements either want to add electrons to their highest energy level or take electrons away from their highest energy level until they're left with 8 in their next highest. So let's take a look at that. Down here, the highest energy level for this element is 3, and there are a total of 7 valence electrons placed there. This is the element chlorine. Chlorine has a tendency to want to gain one more electron. That would give it 8 in its highest energy level. This one has, in its highest energy level, 6 electrons. This represents oxygen. Oxygen has a tendency to want to gain 2 extra electrons. And then we have this one down here where the highest energy level is right here. My pen doesn't want to write. Okay, this last electron configuration that I have way down here at the bottom, I just erased the notation for the d orbitals because I wanted to talk about a different element. This particular element has the highest energy level is 4, and it has 2 valence electrons. If we look at the periodic table and we go 1, 2, 3, 4, and then we count over to 2 electrons being placed there, we'll find out that we're talking about the element calcium. Okay, calcium has a tendency to want to lose 2 of its electrons, and if you look, if we lose those 2 electrons, then the highest energy level is 3, and there are a total of 8 valence electrons. How about that? We'll see you on the next summary.